Good morning friends, welcome back to Brain Sizzlers. In our last video, we saw the correlation between successive percentage increase and the overall percentage increase. In this video, we are going to find just the reverse of it, the correlation between successive percentage decrease and the overall percentage decrease. Let us as usual start with an example. Let us consider a value 150. Now, step 1. If we decrease 150 by 20%, the value that we will get will be 150 minus 20 by 100 times 150, that is 120. So this is the first revised value after an initial drop of 20% from 150. Step 2. Let us further decrease this value by 25%. Now if we further decrease 120 by 25%, the value that we will get will be 120 minus 25 by 100 times 120, that amounts to be 90. So 90 is the value that we get after two successive percentage drops from 150, namely 20 and 25. Step 3. Now let us try to find the overall percentage drop. We very well know that the initial value is 150 and we know that the successive percentage drops leads us to the value of 90. So if 150 is given a yardstick of 100, 90 will be found equivalent to 60. So the overall percentage drop will be 100 minus 60, which is 40. Now if we cross check it with the individual percentage drops 20 and 25, it does not work out to be direct addition. That is 20 and 25 giving 45. It does not work in that way. The overall percentage drop is different, that is 40. We will now try to figure out the mathematical relation between the individual percentage drop and the overall percentage drop. So if y represents the initial quantity and if x1 represents the initial drop in percentage, the first revised value that we will get after a drop of x percentage from y will be y minus of x1 by 100 times y, that amounts to y times 100 minus x1 by 100. So this is the first revised value after an initial drop of x1 percentage from y. This equation might also be pretty much useful for competitive exams, wherein we are given an initial value of some random value for y and some random value for x1, then we can find the revised value. Now if we subsequently drop the revised value by another x2 percentage, for 100 the drop is x2, so the absolute drop with respect to y times 100 minus x1 by 100 will be y times 100 minus x1 times x2 by 100 square, applying the same direct proportion logic that we tend to use in the elementary school level education. So the final revised value comes out to be y times 100 minus x1 multiplied by 100 minus x2 by 100 square. So this equation might also be quite useful for the competitive exams like XAT, CAT, SBI, PO, etc. So x1 and x2 are unequal percentage drops. Now if we tend to find the overall percentage drop, let us denote it by x. So if y is given a yardstick of 100, this revised value given by equation number 2 will be found equivalent to 100 minus x1 times 100 minus x2 by 100. So the overall drop in percentage will be 100 minus of 100 minus x1 times 100 minus x2 by 100. After manipulating, the final value that we get will be x percentage equals 100 times x1 plus x2 minus x1 x2 by 100. So this equation 3 will also be quite useful for all the competitive exams. If we cross check it with the example that we considered earlier, by substituting x1 to be 20 and x2 to be 25, what we will get in the numerator will be 45 times 100 will give us 4500 and x1 x2 product will give us 500. So 4500 minus 500 will give us 4000. 4000 divided by 1000 will give us 40. That's exactly what the overall percentage drop that we got in the example that we considered. Now considering a special case wherein x1 equal to x2, the equation number 3 gets modified to x percentage equal to 200x minus x square by 100. So all these equations, namely equations 1, 2, 3 and 4 will be more than useful for all the competitive exams. If you find this video worthwhile, do subscribe. Thanks a lot for watching.